how's it going today video? How's it going, ladies and gentlemen? Today video I'm gonna talking about how to define the normal strain under the subject of solid mechanics, how subtopic of pure bending, how to define the normal strain, or we call as bending strain also. So that's first we illustrate as this symbol. Normal strain with respect to x-axis is equal to negative y over by rho. So I'm going to explain about how to define this formula that we have here. So let me find my pen. So now we have assumed the specimen made by certain material. So we note this material by 3 points A, B, D, E, and F, G, as you can see right here. So we assume that the DE, it is a neutral surface. Neutral surface, it is where the length after the bending will occurs, it will remain constant. So there is no elongation at the neutral surface for this particular condition. It is DE will have zero deformation. So for the length of AB, we denote as LABI. It is referred to initial condition. Length for AB at the initial condition. And for the length of DE, I'm denoted as L, the pure L right there. So there is a typo letter B. So after deformation, according to the theorem of Bernoulli, we assume that the specimen will deform in the manner of arc, the circle arc. So we'll have an, you see right here, the C in here, that will be the center of curvature. We'll have an AB, DE, and FG. So we'll have a cross section Y and X axis. We'll have a rho that define the radius for the neutral surface, which is DE, and we'll have a Y, which is the distance between E to B. So let's say we want to make an analysis at the AB, the strain, the respect upon the x-axis for length AB, which is this length. We know that the normal, not normal, but the conventional formula for normal strain is equal to the deformation over by the initial length. So in this case, deformation for AB over by the initial length of AB. Initial length of AB, it is nothing but is equal to the length of neutral surface, which is DE. I'm denoted as L. So that's why LAB, initial condition, is equal to L. So L, it is equal to length after. For the neutral surface or DE, will have no elongation, will have no deformation. So the length after and length before at DE is equal. So length L is equal to L after. Because it is the arc, we will deform an arc. We can use the arc length equation, which is 2 pi r times by theta over by 316. So because the r in here, it is rho. C to D is rho. So that's why we can define it as 2 pi theta times by rho over by 316. So that's how to define LABI. For the deformation, we know that the deformation is equal to length after minus by length initial condition. So length after for AB minus by length at the initial condition, we can derive as LAB after minus by L, because L, it is equal to LAB in initial condition. So length LAB after is equal to 2 pi r theta over by 316 degree, because it is an arc, equal to 2 pi theta because the radius. Now we make an analysis at the AB length. let's say that this is the point. So the radius, there will be rho minus by y. So that's why rho minus by y, we choose as our radius. So you bring back the deformation equation downward upon the paper, will get 2 pi theta rho minus by y over by 316, which is the length AB after, minus by the initial length of AB, which is equal to 2 pi theta rho over by 316. Simplify this equation even more, you will get something like this: rho minus by y minus by rho. Thus, we will get negative y times by 2 pi theta over by 316 degree. So now we'll have our deformation at AB. We can finalize this normal strain equation or bending strain equation. So we substitute the normal strain, the elongation, the deformation, and the initial length. We'll get negative y 2 pi theta over by 316 over by 2 pi theta times by rho over by 316. Bring this equation upward upon the equation. We'll get negative y 2 pi theta over by 316 times by 316 over by 2 pi theta times by rho. So we cancel out all of the degree and 2 pi theta. We'll get this equation into negative y over by rho. So that's why we can define that the normal strain in that respect to x-axis, it is depend on the point of analysis, it is equal to negative y over by rho. So that's how we define it according to the arc length formula. So I think that's all for today. Thank you for watching. If you have any advice or advice for me, I'm really appreciated, because I am a student. I make a lot of mistakes, so I hope that you can give me a light of knowledge. So have a nice day. Bye bye.